Have you ever wondered how scientists make discoveries? It starts with scientific inquiry. This process guides learners. They move from observations to broad generalizations. Understanding this process is crucial for scientific literacy. It nurtures critical reasoning and informed citizenship. Firstly, let's define the key components of scientific inquiry. Effective inquiry models share 5 important elements. The first element is question formulation. This means crafting clear, focused questions. Good questions spark curiosity and direct investigation. The second is observation and data collection. Here, learners gather evidence systematically. They choose methods suitable to their questions. Next is pattern recognition and generalization. Learners compare observations to find regularities. They can then propose hypotheses or generalizations. The fourth step is testing and refinement. Inductive inferences must be scrutinized through experiments. New data can lead to revised claims. Finally, we have argumentation and explanation. This involves constructing coherent, evidence-based explanations. Now, let's explore pedagogical models. These frameworks implement inquiry principles in classrooms. The first model is the 5E model. It stands for engage, explore, explain, elaborate, and evaluate. This method promotes curiosity, hands-on exploration, and assessment. Another model is the learning cycle. This emphasizes exploration and application of scientific concepts. By repeating the cycle, learners reinforce their understanding. Next is argument-driven inquiry. Students formulate claims based on evidence and engage in debate. Inductive teaching sequences present cases for learners to analyze. This encourages knowledge construction through comparison. Each model scaffolds learning effectively. When designing inquiry lessons, it's essential to balance openness and structure. Start with phenomena that provoke curiosity. This ensures exploration opportunities that are rich and accessible. Support learners in planning investigations by modeling control of variables. Encourage iterative cycles of investigation. This means students should revise hypotheses as evidence builds. Emphasize epistemic practices. Help them separate observation from inference. Finally, incorporate technology wisely to aid in data collection. Assessment of inquiry skills is crucial. It should include process and product evaluations. Use rubrics that define criteria for effective inquiry. Lab notebooks and presentations serve as evidence of learning. Additionally, peer and self-assessment develop metacognitive skills. This encourages students to reflect on their reasoning. The relevance of scientific inquiry stretches across disciplines. Take environmental investigations, for example. They integrate science, geography, and citizenship education. Inductive reasoning is vital in various fields, including history and mathematics. Teachers must cultivate an understanding of science's provisional nature. This prepares students for engaging in civic debates. In summary, scientific inquiry and inductive thinking provide a structured framework. They enable learners to ask meaningful questions and gather evidence. When approached thoughtfully, these strategies foster understanding and critical thinking. If you're excited to dive deeper into scientific inquiry or try it in your classroom, follow our channel for more engaging content. Let's explore the wonders of science together.